All right. Hi, everyone. Thanks so much for coming along. We are day one, so no excuses for being tired yet. My name is Damian Brady, and I have been to a number of NDCs, but this is the first time I've been to this event in Copenhagen, which is probably understandable seeing this as the first one, right? Okay. Um, yep, good start. Um, I have been to Copenhagen before though, and I love it. So I kind of jumped at the chance to come back, and it's going really well so far. I'll let you know in an hour if it's still going well. This conference though, I've been to a bunch of NDC conferences, and I love them because there is a breadth of information you can learn. There's a huge breadth of talks. But I used to go to the events and I used to go and see the talks which would talk about the really intricate detail of languages and the new language features. I think the same time tomorrow, Mads Torgersen is speaking about what's new in C Sharp, and I loved those talks. They were amazing. You know, you could see the new syntax that you get to use and the beautiful, elegant ways that you can write the code to solve the problems that people want. And I love that. But today, I'm going to talk about almost the opposite, which is that even though we have all of these amazing languages and amazing technologies, the code that you write day to day, in the scheme of things, is just a small detail when it comes to delivering software. So I'm going to start by getting everybody offside immediately. Who here is a developer, by the way? Okay, that's approximately 100% of the people in the room. So I've probably lost a bunch of you already. Is there more to life than code? Now we love code, and I love code. I love elegant code. I love elegant architectures, ingenious algorithms, and we all do that. We argue about frameworks, and we argue about dark mode, and we pretend we understand recursion, and we argue about the correct number of indents to use, which is 2, by the way. And look, I love the code. I love these languages and the new language features. And for example, yesterday I was at an event and saw somebody talking about language features for .NET 7, and one's coming up for .NET 8. So this is, I've been a .NET developer for a long time. This is kind of a standard class. This is a pretty standard way of writing it. It's a customer class. It has a name and an age and like a say hello method. But with some of the new language features, primary constructors that came in .NET 7, that can become this, which is, beautiful, right? And elegant. This will save you several seconds when you're typing that, right? But really, the left code and the right code compile to exactly the same IL. So it's not going to be any faster. It's just fewer characters. And realistically, if you use something like GitHub Copilot or Whisper or any of those other AI tools, it's going to write the stuff on the left in a fraction of a second anyway. But it's still very nice. And by the way, I know that it writes that in a fraction of a second because that's how I did this. Actually, let me show you. So this is Copilot, or GitHub Copilot. I literally recorded this like a few minutes ago. And so, the language features are lovely and they're great, but also, it's going to compile to the same thing. And in the scheme of things, writing that code more elegantly and more beautifully like that, does it deliver value to a customer more quickly? Does it ensure that you're writing the right code to solve the problems? Well, no, not really. So the point of today's talk isn't to say that the code is not important. Sure, it's absolutely important. It's the core of everything we do, right? But I want you to just think about the broader picture and what affects the delivery of value a little bit more than what the code is. And we're going to talk about some of that now. When I became a developer, when I had my first job, I remember going to a job interview and they said to me, all right, in this job interview, we would like you to write some code to sort a list. Now, if somebody asks you that today, this is the correct answer, right? If you write anything other than this, you have wasted a whole lot of time, right? Because we've solved that problem, right? If you are writing your own sorting algorithms, you're wasting time. And I hate to say it, the compiler is better than you, right? it is better at writing more efficient code than you. Even if it wasn't, like even if you wrote code which was terrible and the compiler compiled it to something that was terrible as well, computers are fast enough now that they can just kind of gloss over that problem. There are some exceptions, but for the vast majority of probably people in this room, we're writing forms over data. And if you need to sort 1 million customers, it's going to take a fraction of a second on the hardware that you have, even if it's an incredibly inefficient algorithm. And yes, there are more efficient algorithms. You should probably not try to roll your own and think it's going to be very efficient. Sorting algorithms I love them actually. My favorite one is, I can't remember exactly what it's called, but it's like the multiple universes algorithm, where you just look at the list and see if it's sorted. And if it's not, then you destroy the universe because there's another universe where it is sorted. It's very hard to implement. But it wasn't always like this. Like it's so much easier to write code these days, and it wasn't always like this. Now, I'm sure many of you have seen something like this. This is a punch card. I think this is Fortran on this. Not that you'd be able to tell, it's just a series of holes. And I know you've seen this before, but I want you to really look at it and try and think about how this compares to how you write code today. So what used to happen was developers would sit down and they would write very low-level instructions on what they called coding sheets. And by low-level instructions, I mean that you could write a number to a register and you could add or subtract registers from each other, and that was about it. That's the only thing you could do, right? So you have these coding sheets, and then they would manually go in and punch holes in these punch cards and build these gigantic stacks of these punch cards. And then you would rent time, probably at a huge expense, on one of the few computers that existed in the world, and you'd run the cards through and hope that you got it right. Now, in that context, think about how much value there is in knowing a faster algorithm or a better way to do something. It's huge, right? If you can do this faster than the person next to you, you have saved a significant amount of time. Right? Back then, somebody who could write efficient, well-written code that ran really well each time was hugely, hugely valuable. But these days, we have it much, much easier. There is a pattern that happens with all technology where over time, human knowledge kind of builds on human knowledge, and we build frameworks and tooling, and we build code on code and so on until we don't really realize what's going on under the covers. We have this really highly abstracted way of writing code. We don't have to think about what happens underneath or how hard it once was. And if you compare the way we write code these days, or if you compare the way that they wrote code with the punch cards with the way we do it these days, the state-of-the-art programming these days is you open ChatGPT and you try to explain what it's doing, and then you copy-paste that code blindly into your editor, which is supposed to be a joke, but nobody laughed, which is disturbing. But then you just push it to the server and you compile, and there's a pipeline that compiles and runs all your tests and then deploys it out to an environment. And if everything's okay, it'll be in production, running in this completely virtual space in the cloud managed by a $1 trillion company for you. You don't have to think about any of that stuff now. But in that context, think about how much value there is in knowing how to write a slightly better sort algorithm, or being able to write an algorithm slightly better than the person next to you. It's not zero, right? There is value in that, but it's kind of trending towards zero, right? So at this point, I'm going to switch, and this will be a thinly disguised DevOps talk. Not really. In about the late 2000s, thanks to people like Patrick Dewar, we were introduced to this concept of DevOps, and that the ideas behind DevOps weren't new. They'd been around for a long time. But we talk about DevOps as this idea of being able to align everything, your processes, your people, your software, your tooling, everything, in order to deliver products into the hands of users as quickly as possible so that you can iterate on them, learn from what's in production, and make sure you're continually providing value, right? The bit that we kind of don't think about very much is that what made this possible, or what made this important, was that the code was no longer the bottleneck. Right? We shifted the bottleneck away from the actual implementation, the code. That was the kind of easy bit. If you could put it in production quickly, that has huge benefits. So because the state of the art changed and it became so much easier to implement features and implement functions, this was now where we focused our attention. Now, who's seen a diagram like this or some image like this? Yeah, I asked this at the last place as well, and I was expecting everybody to put their hands up, but it was about half here as well. So this is kind of your general idea of what DevOps looks like, and I've seen 100 different versions of this. This is the one which this is the one that came from Microsoft marketing team, so it's very beautiful. But I want to show you like that in a different way. This one was written by me, drawn by me. I don't know if you can tell. So if we just pretend that the coding part is solved, right? And I'll come back to that. If we just pretend the coding part is solved, what we're talking about is the plan and the delivery of that plan. So making sure that we're doing the right thing, and then making sure that that gets into the hands of customers so we can learn from it and make more of the right thing. So at one end, we had agile and agile techniques, right? Where we realized that the waterfall method, or more accurately, big upfront planning, was a bad way of doing things, because we would commit to something at the point where we knew the least about what people wanted. And so we have these agile techniques to make sure we're delivering the right thing. We're going to build the right thing, right? So we plan minimally. We kind of put these ideas of stuff that's going to happen, and then we build on them when it's time to expand, and we constantly adjust and groom our backlog, and we do all that kind of stuff, right? But as a result, it means that we can't really focus on how quickly we can get all of the things in the backlog into production, because some of the things in the backlog might never get to production because it was an idea that fell flat, or we tried it and it didn't quite work. So we focus on things like velocity. And there's still misunderstandings, right? Velocity quite often gets referred to as speed, how fast you can get stuff into production. But the word velocity doesn't mean speed. The word velocity means speed in a direction. And if you're going in the wrong direction, then you're going really fast off the side of the road, right? You're not going to succeed. You're not going to get where you want to be. You're not going to provide the value. So going really fast in the wrong direction is terrible. So our planning, our agile tools have meant that we can continually adjust what we're doing, and we can be going in the right place, right? And then at the other end of this, the delivery side, is the CI/CD stuff. So can we continuously build and run all of our tests? And then importantly, can we put it in the hands of customers really, really quickly to learn whether it's solving the problems that they want to solve, right? I've been doing DevOps stuff for about 15 years-ish, and I can confidently say that the CI/CD part of it has the biggest impact in how well you deliver your software. It is, in the scheme of things, relatively small effort to put together a pipeline to automatically build, test, and deploy your application, or get it into a deployable state if you're just doing continuous delivery. And it's relatively simple effort, and you get a massive, massive increase in the ability to deliver working, effective, valuable code. So it's absolutely right that we focus on these things and forget about the code. But now this stuff is kind of table stakes, right? Most people, and I'm going to put people on the spot, most people I'm guessing have some kind of CI/CD pipeline. It doesn't have to deliver all the way to production, but is that pretty fair to say? Most people will have some kind of pipeline, yeah. So we're kind of swinging back again, and we're thinking, well, what's the next bottleneck? By the way, the real power of CI/CD, and this is something I like to talk about, the real power of CI/CD, the best analogy I've heard is in, I think it was in just before the 1900s, in 1896, Sakichi Toyota built, or was responsible for, the power loom. So a loom is one of those things with the shuttle that goes back and forth, and it threads and it creates this textile, basically creates fabric, right? And they used to have a single person in a factory at each of these machines, and they would do the pedals, or I don't know how they work. They do the pedals and the shuttle goes back and forth, and they do all that sort of stuff. The automated ones, or the power loom, or the predecessors actually to the power loom automated this process. So now instead of a factory floor full of people, one on each machine, you could have a factory floor with one person overseeing all of it. And they would just do their thing. And then if something went wrong, that person would have to sprint down and stop the thing and then try to untangle what was going on and undo it and throw away some fabric and stuff like that. But it was so much more effective. The real power with the power loom was not that it was automated, but that it stopped when something went wrong. I want to emphasize that. The power wasn't that it did all this stuff automatically. If something got tangled, it would stop immediately. And what that meant was this person no longer had to sprint downstairs and stop it and untangle things. It meant that this bad situation would not continue. So the analogy to continuous delivery in your CI/CD pipeline is if something goes wrong with your code, a test fails or it doesn't compile, it will not get into production. A robust CI/CD pipeline is just as much about preventing the bad stuff from getting into production as getting the good stuff into production. Speaking of production, the other thing that CI/CD is great for is putting stuff in production early so you can test it in production. Now, people like grin and smile at this phrase, test in production, but here's a little tip for you. Every single person in this room tests in production. You might have some other environments you test in first, that's fine, but production is the only environment that has your actual customers using real actual data in a real world situation, right? And you can try as much as you want, but you cannot duplicate that. You can get close, sure. In some industries, you can get close. In others, you pretend you get close. But everybody tests in production. So really powerful organizations, the ones that deliver value, care very much about being able to react when stuff goes wrong in production, because it will go wrong in production. If you have a great CI/CD pipeline and something bad gets into prod, just knowing you can fix that bug and push into production really, really easily is extremely powerful, right? So all of these surrounding things are not your code, right? Yeah, the code, maybe if it has a bug, that's fine, but the CI/CD pipeline is the thing that fixes that. And if you do not have that pipeline, it is not robust, then your code will cause the problem, but it's the surrounding stuff that gives the value, if you get me. So you can write the most clean, beautiful, elegant code, but if it's the wrong thing, you've written trash, rubbish, garbage, right? Beautiful, elegant garbage, right? And I've written my fair share of beautiful, elegant garbage before. By the way, if your feature sucks and it gets into production, there is a big, big difference between saying, hey, customers, I spent 6 months on this feature, it's exactly what you want, have a go. And they say, yeah, cool, that's terrible, I'm not going to use it. If that took you 6 months versus, hey, we're trying this thing, we've put it out there, if you want to try it, just turn the flag on, have a look. You know, we started it a week ago, and they say, that's terrible, we don't want it. You go, all right, great. There is a huge, huge difference. If it's taken you 6 months and you've invested your team 6 months, that's a career-ending decision that you just made, right? If it's a week and you change direction, then you have embraced testing in production, and you can change direction much, much faster. I used to work in government, by the way. This is pictured here is some of those government projects. Beautiful, elegant garbage. But for a lot of us, right, as developers, we don't really get to decide what features we write anyway. Right? I'm talking about making sure that you're building the right things. But for some of us, for a lot of us, you get told, here is your backlog, go do those things, right? And you just kind of have to trust that they're the right things to do. Who has worked? Actually, no, I'm going to ask a different question first. Who is sitting very physically close to their manager right now? Wow, that's a lot. Okay, you're exempt from the next question. Who has worked for a terrible manager before? All right, that's a lot of people. I have as well. And for me, a bad manager is somebody who, for whatever reason, leads you to spend a lot of time doing things that do not contribute to building value for customers, right? Whether that be implementing the wrong work items or sitting in everlasting meetings or having a daily hour-long stand-up where everyone says, yesterday I worked on this, tomorrow I'm working on this, I have no blockers. Yeah. You as a developer, though, are hired to code. You're hired to implement ideas and put them into the hands of customers, right? Anything that takes you away from that, that is not valuable, is a waste of time. I once worked at a company and I had a manager who, or a tech lead, but also a manager who had a meeting. He held a meeting at the start of a project to decide whether database table names should be plural or singular. I mean, there's probably some opinions. His opinion was that it should be singular because then the class name matches the table and it makes that a lot easier. And so you can create a customer and then it matches the customer table. There was another senior developer and his opinion was that it should be plural because you're storing lots of customers in this table. It just makes more sense. This meeting went for 2 hours. I'm not exaggerating at all, 2 hours. My opinion and the opinion of most of the other people who were stuck in this room for 2 hours was, who cares? Like, pick one and let's move on. I'm genuinely convinced the only reason that meeting stopped was because the senior dev who had the differing opinion lost the will to live and needed to exit to calm down for a bit. But that 2 hours is an absolute waste of time, right? The code that you write, whether it's going to say customer or customers, nobody will care about that 10 minutes from now. The worst thing that's going to happen is a developer might come along later and say, why is this singular? That's weird. It's always been plural in the past. Okay, and then they keep working, right? That is a waste of time. So that is a bad manager, right? That is somebody who is spending your valuable time on things that ultimately do not matter, right? But it's not always the manager's fault. Sometimes it's the process and that comes from above the manager. Has anybody worked in an organization where the direction has changed or the features that were the highest priority have changed fast enough that it feels like you never get anything done? Yep. Was it a sales-driven organization just out of, yeah, okay. Yeah, I worked there too. And that can be problematic, right? The processes are there such that your direction continually changes and you keep being told, write this, it's very, very important. And then a week later, scrap that, do something else. Now that's a tricky one, right? Because you do need to change direction. If you're writing the wrong thing, you do need to change direction. But before I go into that, for various reasons, poor management can be hugely impactful in a negative way to the delivery of software to customers, the delivery of value to customers. So much so, in 1944, the Office of Strategic Services in the US, which later became the CIA, actually published internally, it's now declassified if you really want to look at it, a handbook on how to sabotage organizations from the inside using management strategies. I think I've worked at a few places that have read this and just didn't see the title. I'm going to give you some examples, and I tried to narrow these down, but I ended up deleting like 2 of them because they weren't relevant to software engineering, and the rest seem to be. So anyway, here's some examples. Insist on doing everything through channels. Never permit shortcuts to be taken in order to expedite decisions. When possible, refer all matters to committees for further study and consideration. Attempt to make the committee as large as possible, never less than 5. Haggle over precise wordings of communications, minutes, and resolutions. Refer back to matters decided upon at the last meeting and attempt to reopen the question of the advisability of that decision. Another one, insist on perfect work in relatively unimportant products and send back for refinishing those which have even the least flaw. There's also hold conferences when there is more critical work to be done, but I think we can overlook that today. But in general, right, do these sound a little bit familiar to you? I've worked in plenty of organizations where that seems to be what happens. There was an organization, it was a government organization, where their rule for any deployment was it needed to be signed off by the heads of all of the different teams, whether they were involved or not. And there were about 8 or 9 teams. And if the person was away, you couldn't get somebody else to sign it. You just had to wait for them to return to work. Obviously, we didn't have continuous deployment here. That was not a thing. But that kind of process is something that gets in the way. Weird that this slide came up when I'm talking about process that gets in the way. This is the diagram for SAFe, Scaled Agile Framework. And the process itself, like processes can be important and they can be valuable. They can bring value to organizations. If you know when you write this feature, if you commit with a particular type of message, then this will happen. It will automatically go out to production. If it passes all the tests, it goes to these environments. You know, if it involves this team, then you need to notify that team beforehand. Some of those things are really, really important. The problem is when the process gets in the way of actually delivering value, and it's process for process sake, right? I keep talking about the same company, but I'm going to pretend it's a different one. Organization, government, weirdly, that I worked for, there was an instance, we as devs were not allowed to touch the databases. Not just production, but even our dev database where we ran our tests and things like that. We had to go to the DBA team and we would give them the SQL script to say, this is how I want you to update the table so we can run our application on our dev servers that we had to log out of our machine and log back in as the testing account, and a whole bunch of other process there. But there was one instance where we updated a database table for our dev environment and we gave it to the DBA team and said, can you apply this to the dev environment? And the DBA looked at it and he said, yep, looks great, and ran it in the wrong window and ran it in production. So production went down. And it wasn't an important system. It was just, this was at a, I'm just going to stop myself and work out whether I can say this. It was an important system. I'm not going to say that. It was an important system, right? But it went down in production, which impacted a significant part of the government operations, right? But there was process in place. So we couldn't just run the fix, which we came up with in a minute or two. We had to go through the process to deploy that fix because there's a process. We should have done that the first time. We didn't, that's fine. Well, we got to run the process. It took 6 hours to go through that process to run a SQL script to fix that issue. In the meantime, 6 hours of outage because that process existed for a reason, apparently. But that's one of those scenarios where you need to be able to expedite the decision, right? It's a break glass situation. That process got in the way of being able to deliver value, which in this case was getting the thing working again. And that's not an uncommon scenario in a lot of organizations. Just to drill home the point about bad management, this is a guy called Albert Goering, who's the brother of Hermann Goering, who was the founder of the Gestapo. Albert did not share those same, goals, I suppose. In 1939, Albert Goering here became the export manager for Skoda in Czechoslovakia. Right? Famously, he forged his brother's signature a number of times to get some of his workers out of Czechoslovakia when Germany invaded to ultimately save their lives. But one thing that's less well known and is not actually proven, this is alleged, but apparently he started using deliberate poor management techniques, some of which made their way into the CIA handbook, to hamper the delivery of automotive products that the Nazis could then use for the war, right? So by implementing really poor management, he was fighting Nazis, right? That's how bad management can be, right? Doing this from the inside. So I've talked about bad managers. It's all been doom and gloom, right? Good managers, though, can have multiplicative, I got it, effects on how well you can deliver software to. I remember some of the best managers I ever had, or one in particular, the best manager I ever had. After the fact, we didn't call him this to his face, but after the fact, we referred to him as the shit umbrella. Now that sounds like a terrible nickname, and it's probably not something you want to call someone directly. But it occurred to us after he left just how much he was protecting the team from things that we didn't need to care about, right? He would basically hold an umbrella over us And the stuff that came from management, if we did not need to know about it, we wouldn't hear about it. We just got along with our jobs, just got on with our jobs. I mainly worked out that this was what was happening when he left and handed me the umbrella. And I'm like, wow, this thing is dirty. But he was so effective because he understood what management actually wanted and what parts of that were relevant to the team. And not all of it was. There was a huge amount that wasn't relevant to the team, but he focused on making sure that what we were doing was delivering value, right? And the most effective managers, by the way, there's no relationship between that slide and this slide. I noticed that while I was creating them. I feel like maybe I should switch them. He was able to talk to both teams, like both groups of people, developers and managers, right? Because usually, language-wise, and the language that we use in business is very different. Managers speak an entirely different language to developers, and it's very rare to find somebody who can speak like more than one of these languages. And as I'm saying that, I'm realizing I'm in Denmark, and you all speak 12 languages. I'm from Australia, we speak one language and we do it very badly. So for me, that analogy fits really well. But it's rare to find somebody who knows how to speak to developers effectively and how to speak to managers effectively. So if you are in a position where you get instruction from management and you pass them to a team, this is definitely something worth focusing on. All right, back to DevOps. I've been subtly shitting on software development and actually writing code, but I want to be clear that that is not really the intention. It is very, very important to write code effectively. Like that is the vast majority of what we do. And in fact, I have a problem with this diagram in general. I use it a lot, but I have a problem with it because out of all of these four like segments, ship, learn, idea, and build, the build part is just one of them. And that is what we do for 90% of our day, right? It's a bit like we're saying, okay, we ship this product and when the customers give us feedback and we learn how they're using it, and then we analyze their usage patterns and we ask surveys and we make sure that they're happy with it. And if they're not, we feed that back into our backlogs. We build these beautiful backlogs, we specify everything beautifully, and then some people do some stuff. And then we put it into production and we learn from what's happening in production, right? We kind of gloss over that build part, but that's most of what we do time-wise. So going back to the other beautifully drawn diagram, there's this inner loop as well as the outer loop. So the plan and delivery is what we call the outer loop of DevOps. And then we have this inner loop where we write code and we test that code and we deploy that code. And this has to be an efficient process as well, right? When we talk about CI/CD, we talk about that being a mechanism by which we can learn and change direction. We can change our backlog. We can learn what we need to do and change direction. But it's just as important to be able to change direction in this inner loop as well. Like we have to be able to switch tasks and context switch. And so we need to optimize for that day-to-day work. I was mentioning before that the CI/CD, the whole DevOps outer loop stuff came about because the writing the code was the bottleneck. And now that's kind of table stakes. We all do that anyway. And now we're working out that the inner loop is pretty inefficient too. So there are ways that we can improve that inner loop in order to deliver value faster. And yes, some of that is better language tools and better languages and better syntactic sugar and stuff like that, but not a lot of it, right? A lot of it is other things like better tooling, better architecture, branching strategies. If you can just drop a branch and create a new one and work on a different feature, that's hugely valuable if you're able to do that in your organization. Dev environments as code. So here's my pitch for one of the things that can be hugely valuable, which is when I first heard about it, I kind of was a little bit underwhelmed, but in hindsight, it's incredibly powerful to be able to have these ephemeral dev environments. So developer environments you can just spin up and throw away. It means that you can context switch so quickly. If your manager says, hey, there's a pull request, it's super urgent, I want you to analyze it, you don't have to just go to the web and like read through the code and say, it looks okay. Or look at the top where it says 4,000 files changed and go, not reading that, looks good to me, ship it. Being able to actually just switch to that environment, that pull request, and compile it and run it and be like, okay, that's great, and then tear the whole thing down and keep doing what you were doing, hugely, hugely valuable. Here's my one marketing slide. You can really tell with my slides whether I did them or not, can't you? Did not do this one. So CodeSpace is a GitHub product. It's one of the ways you can do it, but it's based on a technology called dev containers. If you go to containers.dev, that is an open spec. You don't have to use GitHub Codespaces to use dev containers. You can use that just in VS Code locally if you have Docker. There are a bunch of other alternatives for it as well. You get some of this for free, so use that. You should all pay us money to buy this as well, though. But if you don't, I'm not revenue driven, so it doesn't affect my job at all. But that idea of ephemeral dev environments is really valuable. It means that you can context switch and change directions really quickly. Jump onto another project that needs an entirely new set of frameworks really, really quickly. At GitHub, by the way, we started using CodeSpaces well before it became a public product, and our onboarding time, so when a new developer came in to GitHub and started writing code, it used to take a few days to get their environment set up and make sure they had all the dependencies and the IDE was ready and all that kind of stuff. And so they could write code and debug. GitHub.com, by the way, is, I think it's 11, it might even be 17 gig on disk. It's a monolith, a Ruby monolith. So it went from a few days to now a new developer at GitHub can be compiling and debugging code in about 15 seconds. Because they just spin up a new environment and it's got everything ready to go. If you need the whole machine as well, Microsoft does a thing called dev boxes, which is the same idea but an entire Windows box. And you can spin it up and tear it down really, really quickly. But that idea, whether you use CodeSpaces or an alternative, is incredibly powerful for being able to change direction. Now, the other thing that's really valuable for being able to change direction is the software architecture, the way you write your code. Right? Controversially, Facebook used to have a policy, this is a while ago now, I don't know if they still do, where they would not delete any code. There were a ton of lines of code in their code base that could never get reached, which we call dead code, right? There is no code path that will take you to that line of code. But they didn't want to waste the time getting rid of that code. Instead, they wrote new code and directed to that. Now this, when people hear about that, they're like, that sounds horrible. Like, there will be millions of lines of code that are just going to completely disrupt what you're looking at. Like, oh, I think I found the line of code that does this thing. Oh, nope, you can never reach that code. Okay, let me look for another one. And I get that. There is technical debt in that. But dead code can actually be really, it can be a sign of a great organization's ability to change direction. So let me explain, right? I use this for a different talk about ways to change direction quickly, essentially, about abstraction is your friend. So let's imagine you have a weather component in your application and you use Google. And so you have this class called a Google Weather Provider. And you've been asked to change that to Bing. Now, typically you might create a branch. And in that branch, the first thing you do is you rename this file and rename all the references to it. And then you start going through the implementation and changing it so it uses the Bing service instead, right? Instead, what you could do is create a branch. And in that, the first thing you do is you abstract away. You have an interface. And then you use dependency injection or inversion of control techniques so that when somebody asks for an iWeather provider, it says, oh, the one we're using is the Google Weather Provider. Here's the implementation. Then you merge that branch into your main branch and deploy it to production. Now, functionally, nothing has changed, right? Your tests are going to check whether you've done this correctly or not. But everything's in your main branch now. And functionally, nothing has changed. You've got exactly the same code. But what this allows you to do is just start implementing another one. You can just start implementing a Bing weather provider. And if you get halfway through, as long as it compiles, you can still deploy to production because this code doesn't get called. It's dead code. You could even get it to a point where you think it's probably about right, and then attach a feature flag to it and ask people to try it out. And if it doesn't work, you turn the flag off and go back to the other one. Right. But when you're ready, you can then say, well, now we're going to resolve to the Bing weather provider, and you have this dead code in the old one, Google weather provider. And if you want, you can go back and clean that up. Now, what this means is you can change direction. If I was halfway through the implementation of that Bing weather provider and I was told, do not do any more work on this, we have 12 other things that are higher priority, I can just abandon it and not worry. I don't have to unravel what I've done or undo that code, or just leave that branch to get stale and come back to it 6 months later and think, oh God, what was I doing on that? I might just start again, right? So that in that respect, dead code is actually really powerful. The other thing that helps with this, of course, is feature flags. So same idea, you have your existing code, you write the new code to do that work, attach it to a feature flag. So when you think you're ready, you turn that flag on, or you turn it on for some people, and the code base just redirects to the new code. These two techniques, those two things, are really powerful tools for optimizing for context switching. So doing those, and yes, some of it is code, some of it is architecture, some of it is code, but some of it is tooling and some of it is process. Those things have much more impact on you being able to deliver a product that does the right thing into the hands of users effectively and efficiently. All right. What a rant, right? What's my point? My point is that your work, like the work that you do day to day, is absolutely important, right? Writing code that is clean and efficient and maintainable is extremely important, right? But don't over-index on it. Realize that as long as the code works, there is a lot more that can have a much bigger impact on whether you're delivering value to customers than just, whether you've used this new language feature. Now, this is a really common thing for people in leadership when it comes to, hey, we need to write this new feature. I remember being a dev thinking, we're using this technology that's, 3 versions old now. We need to just wipe the whole thing and write it in the new framework. Yeah, there's not a lot of value in that, frankly. And the more you do software development, the more you're like, that would be lovely to do, but also it works right now. So we can spend all this time getting the same functionality in a newer framework. And yes, there are advantages to using newer frameworks, absolutely. But is it more advantageous to fix the bugs and to work on some new stuff, or even better, to improve your process so that when you put something in production, your customers are going to get the value out of it straight away? So yes, your code is absolutely important. It does need to be maintained, so make it maintainable, make it readable. But there's more that goes on. Now, if you have control over some of these decisions, more than just how you write your code, start thinking about how you can optimize for the developers in your organization. And when I say optimize for the developers, I mean thinking about this in a broader sense. Their day-to-day work, how do you make that easier? One of my favorite DevOps researchers and experts is Gene Kim, and he talks about the 5 ideals. I would strongly recommend if you're looking for something to read around this, the Phoenix Project was the first kind of book of his. Absolutely recommend reading that. And then his second one was, and I know I'm going to, the Unicorn Project. Right? The Unicorn Project, he introduced these 5 ideals. By the way, these are books about DevOps, but they're written like novels, so you can actually read them and not, want to just immediately go to sleep. They're really readable books. But the 5 ideals talks about the 5 things that happen in organizations that are ideal for the delivery of software. And one of those things is, well, there's 2 that kind of matter. One is focus, flow, and what's the other word? This is the bit that I didn't prepare, by the way. Focus, flow, and joy, which means as a developer, can you get into that flow state and keep doing your work? And the other one, which I can't remember the exact words, but it is about localization and being able to, can I do everything I need to actually deliver value, or do I need to go over to another department, for example, the DBA department, to ask them to run the script for me so I can test my own code? So locality and simplicity, I think, is the way he puts it. If you can optimize those things for your developers, they're going to be happier, they're going to be able to write code faster and implement those things faster. But realize this is not about how efficient and effective the code is. This is about making their lives easier with everything that surrounds that code. And if you can optimize for developers, ultimately you're optimizing for delivery. You're optimizing for being able to put features in the hands of customers. And ultimately that is what we are trying to do. I think Scott Hanselman spoke about it in his keynote. That is the ultimate goal, is to build software to help other people. So yes, optimize your code, make it look beautiful, make it efficient, make it elegant and beautiful. But realize that in the big picture of things, the code you write is just a detail. Cool. Thank you. Now, I'm pretty sure we have time for questions if anybody wants to like completely argue with me on anything I just said. Yeah, there's a mic here as well, so we'll do that. And if there are no questions, I'm just going to absolutely assume that everything I said, A, resonated, and B, changed your minds, and you're now like spinning with ideas of how you're going to change your organizations from the inside. By the way, those stories, just while I'm talking and nobody else is, I feel like I'm doing a lot of the work in this conversation, by the way. Those stories, did they resonate with people? I've done a similar talk to this, and people are like, you sounded like you were describing my last job. Is anybody, I saw some nods there. Yeah. And this is genuinely a big problem in our industry, right? We optimize for things that are less important because they're exciting, they're interesting, you know, they're fun. We want to learn how to do the new stuff. We want to learn how to do AI, but we're delivering software and all of the peripheral stuff is far more important.
Yeah. Just a small question. What was the name of the two books again?
Oh, the Phoenix Project was one. And let me just do this just in case. Let's do guest mode. Take the bins out. Cool, thanks. So one is the Phoenix Project. Oh, internet helps. You know what I'm going to do? I'm going to do this. No, how do I do the thing? And it displays. You know, I am one of the very rare people who uses a Mac and a PC, and so I use my Mac at home. Sorry, I use my PC at home, and I use my Mac when I'm traveling. And they changed how this is extended. Oh, you know what? I'm just going to do this. All right, the Phoenix Project and the Unicorn Project. Both are by Gene Kim. There you go. That was elegant and beautiful garbage, what I just did then. These books are both like genuinely readable books. I cannot recommend them enough. Some of them, depending on where you have worked, can be a little bit PTSD inducing. I definitely remember reading the Unicorn Project. There's a bit in it, I'm not going to spoil it. It's a book about DevOps, but I'm still not going to spoil it, where they're talking about a meeting that's happening after a failure that happened in production. And I struggled to read that, not because it was not readable, but because that I've been in that meeting before and it was horrible. So yes, very relatable books, but they have amazing messages in them. And they're actionable kind of things as well. So yeah, highly recommend those.
A question?
Yes.
So I'd say I've been working in a few places where the workplace bears some resemblance to Parts Unlimited, the company from those two books. And the question is in regards to developer workstations or just workstations that you get that are often optimized for, I'd say, office work. And it seems to be like a big hassle getting any type of development tools installed.
Yep.
Apart from something like code spaces, do you have any organizational practical tips on that?
I did until you said apart from something like code spaces. I've been in that situation before. So one of the things, and I've spoken about this in other talks in the past, but one of the things that can be valuable is quantifying the cost of not having the tools you need to do your job. And it's a difficult thing to do. Like if you say, hey, it took me 3 hours to get this thing installed and then I had to fill out all this paperwork. What does that 3 hours actually cost? Well, there's my hourly rate or my salary, but then there's the salary of the people who had to read my emails and reply to them. And then there is the cost of the work that I was not doing as a result, the opportunity cost that came in like that. Ultimately, and then you multiply that by how many people are on your team. And then there's the non-quantifiable stuff like, now I hate my life because I just spent 4 hours, and I don't want to do work for the rest of the day, right? My general opinion with stuff like that, and if you really want me to go into it, there's a previous recording from an NDC, I think, where it was a talk I did called Doing DevOps as a Politically Powerless Developer. That's a lot of words, which I can't type. Ooh. Yeah. My general opinion with that is as long as you can quantify that and put a dollar amount against it and show you're working, it doesn't really matter how precise that dollar amount is, as long as it's in the ballpark, right? But that, if you can track how often that happens and what the cost is with some kind of calculation, that can sometimes go a long way to convincing people higher up that, well, you know what, we are actually wasting a lot of money. Maybe we revisit this decision about having to give developers 3 different accounts or a machine that doesn't work. And their decision might be, no, we're going to wear that cost, in which case the solution is probably get another job. Yeah, flippantly. But yeah, try and quantify it and say, I understand that we're doing this for reasons, but this is what it's costing us as a result. And if that's a dollar figure, that's language that a manager can understand, referring back to that developer manager slide. Cool. Any more questions? I've lost my timer, so I don't know what time it is. 12:33. Cool. It's lunch. Oh, is it lunch? Am I in the way of lunchtime? Okay, last question.
Hi. Hi. I have a question. So when you make this continuous delivery process, I worked in companies where we did that. So far, it worked, have really short releases. But before, you need to ensure, also when you deploy on production system, of course, before you need other system, test environment, whatever. Mm-hmm. But how do you convince the managers, and I was also a manager, head of a development department, how do you convince the upper management that you also need all those automated testing? I mean, you need to write test cases, unit test cases, and also, front-end test cases. So, I mean, how do you convince them when you don't have that in place? It's quite difficult to ensure that it will work in production.
Yeah, I 100% understand what you're saying. So if they haven't seen the bad stuff that can go wrong, it doesn't exist. So risk is a really hard thing to just to show to management. I'm going to answer this in a similar way to that previous question. It's difficult if something's never gone wrong, right? If you write code and you run the tests locally and then it goes into the pipeline and it gets into production, and then while it's in production, it hasn't failed before, then what is the value of adding more to that process to prevent failure that hasn't happened? That is a really hard thing to justify. I would stop short of saying introduce a bug, but that would solve the problem. I think again, turning risk into a quantifiable number to say, all right, it's difficult if it's never happened, but if we have this bug, right, this is how long it takes us to get through our pipeline, maybe an hour, 2 hours or something like that to get into production. If we have a bug in production, it's going to take another maybe hour to fix that bug and then another 2 hours to get it out. So that's 3 hours of downtime where things have gone wrong. If we add another 10-minute process to our pipeline to run all of our tests, that scenario will not happen. So the cost here, the potential cost is X dollars. The cost of implementing that extra piece of pipeline is Y dollars. Work out whether the math is there. But again, really hard to do if nothing's gone wrong. Because do you introduce more process, which is just what I was saying not to do? Do you introduce more process and more work in the pipeline for something that doesn't happen? I don't have a great answer for that. I would try to quantify it as much as possible. Turn risk into a real number as much as you can. Yeah. Unsatisfying answer, sorry. All right, Danny.
I have two things. Yeah, thanks. First of all, I want to give a comment, a reaction on the question. We have a saying, sometimes they need to hit the wall with their face until they will change for the other people. So people just need to hit the wall. But another question really inspiring for me is, how do you quantify the unquantifiable? By example, customer satisfaction, and also just having happier customers, and maybe without having a direct impact on more customers. So how do you measure this extra quality for customers or employers?
Yeah, how do you quantify happy customers? And even how do you quantify happy staff? I believe there is some research that GitHub did around when Copilot came in, because part of the reason that behind Copilot was to get rid of the boring boilerplate stuff that developers don't like and make happier developers, and therefore they're more productive developers. And so there is some research around that. If you search for developer happiness and Copilot, you'll find some studies that we did around that as well. So there is some literature around quantifying the happiness of your internal staff. I'd also refer to any of the work from Dr. Nicole Forsgren, who was one of the, let me just write some more stuff. Everything good about research is attached to her name in DevOps. She's incredible. All of the DORA stuff came from Nicole Forsgren as well. But there is in that literature, in their studies, they have found a direct correlation between the happiness of a development team, so how satisfied they are with their jobs, and not just effective delivery of software, but metrics according to how well the company is doing, according to their own metrics. So the short version is, if you have happier programmers in your organization, your company makes more money. And there is legitimate data behind that. I think Accelerate is one of the, let's do this, is one of the books that she wrote with, I think, Jez Humble, and I don't know if Jim Kim was involved in that one, but Accelerate is the more modern one. But there are direct correlations between happy developers and company performance. So that literature is a good thing to pass on. In terms of happy customers, I don't know of any books and things off the top of my head, but I have heard plenty of stuff around word of mouth marketing being far more effective than explicit, push marketing, I guess. So the best way you can tell people that your company is, or your product is good, is by your other customers independently telling them that it's good, right? Again, I don't have a source for that. There's plenty of stuff out there. I'm sure if you search for something like that, you'll find, like we all do on the internet, you'll find something to agree with what you've already decided. So just do your typical internet search for that. So Quantifying it, though, is a little bit difficult. I would just refer to that research as, look, there is a direct correlation here. This is something that makes our internal team happy, but it's also something that will make our customers happy. And that, just by virtue of doing this stuff a bit better, that leads to better outcomes for the organization itself. Awesome. All right, I will be around for the rest of the week. I'm not leaving until Sunday, so if you see me and you want to have a chat about any of this or anything else, please don't hesitate. And I have shiny stickers here if you want to grab some on the way out. Otherwise, have a good lunch.